to use Green's function to solve the particular solution, or basically find the particular solution. The equation of the Green function is basically above, where we're given the equation y double prime plus y is equal to cosecant times cotangent, and we're given two initial conditions. The first step into solving this is solving the homogeneous, basically setting the right side equal to 0, and we're going to let y equal to e to the mx, take the first derivative and take the second derivative, plug it in, factor out e to the mx, where we're going to just solve as basically the algebraic equation where we get m is equal to 0 plus or minus I, and using Euler's formula we're going to get y is equal to c1 cosine x plus c2 sine of x. Step 2 is take the Wronskian of this, where we're going to let cosine equal to y1, and we're going to let sine of x equal to y2. We're going to take the first derivative and the second, first derivative of both of them, and then we're going to take the determinant of this matrix, and we're going to get equal to 1. So the Wronskian of this is equal to 1. Step 3 is to use the Green's function form. Note that f of t is basically the right side, which is basically cosecant times cotangent. We plug everything in that we found, and here is where it gets messy. So what we're going to do is distribute cosecant t times cotangent t into both of these. And what we want to do is that we want to split it into two equations. And what I decide to do is focus on one part, and then next one is focus on the other part. And from here, anytime we see x or some other variable, we're going to treat it as a constant because the integral is respect to t. So we move the sine of x out. And what I did is convert everything into terms of sine and cosine. And now I have the integral of cosine squared over sine squared respect to dt. And I used the Pythagorean theorem identity to break it up into 2. And after that, I took the integral, and what I got is negative tangent. I'm at negative cotangent minus t. Plug in the balance, and after that, I distribute the sine of x into everything else, and I get the answer for this first part is negative cosine of x minus x sine of x plus pi over 2 times sine of x. Now we want to focus on the second part where cosine is in respect to x, so we move that out. I converted everything in terms of sine and cosines inside the integral. We were able to cancel sine of t, and then we were able to get a simple integral. What I did is use a u substitution, and from there I got natural log of sine of t. I plug in the balance, and I got natural log sine of t, sine of x minus natural log of sine pi 1/2, where we know sine pi 1/2 is equal to 1, which natural log of 1 is equal to 0. I just don't forget the negative cosine of x. We bring that down, and then we just multiply it, and we get negative cosine natural log sine of x. And our particular solution is basically the sum of those two integrals that we just did, which is negative cosine of x minus sine of it, minus x sine of x plus pi 1/2 times sine of x minus cosine of x times natural log sine of x absolute value. And then the general solution is just adding the homogeneous part plus the particular solution, and we have our two balanced. But in this case, the question is going to ask me for the particular solution using Green's function.